Einstein made some rock-solid predictions, from the existence of black holes to the way massive collisions could cause gravitational waves. One of his predictions that hasn't come true yet is the theoretical opposite to black holes: white holes. And while we haven't proven they exist yet, some scientists think they could explain some of the universe's most unexplainable characteristics. So let's talk white holes. You already know that black holes form when a massive star dies and its core shrinks until it's so dense that nothing can escape its gravity. Inside of that point of no return, the star continues to collapse into an infinitely dense point known as a singularity. The singularity is one of the places black holes get messy, at least mathematically speaking. In 1935, Albert Einstein and fellow physicist Nathan Rosen fixed that math by extending the point into a path that leads to a second location. This path was called an EinsteinRosen Bridge, but you probably know it as a wormhole. A black hole is at one end of a wormhole, and that means that the other end is, you guessed it, a white hole. While anything that enters a black hole can never escape, anything that escapes a white hole can never return. At least theoretically. While we know that black holes exist, so far white holes only exist in pages of physics papers. Some scientists say they're probably just imaginary, but there are still physicists who keep coming back to them. In 2014, theorists Hal Haggard and Carlo Rovelli used quantum theory to show that black holes could actually transform into white holes via something called loop quantum gravity. That theory basically says that the fundamental building blocks of space-time are shaped like tiny loops. And since those loops have a finite size, that means a dying star can't actually collapse into a point of infinite density. Instead, right before it reaches infinity, a dying star would experience a quantum bounce that exerts an outward pressure and turns it into a white hole. If true, this could be a solution to the black hole information paradox, which says that even though anything that falls into a black hole can never escape, black holes gradually emit radiation until they disappear completely. That's a problem because information can't be destroyed. A white hole would deliver that information safely out the other side. Anyway, the black-to-white transformation would happen in a few thousandths of a second. But because time dilates in the presence of gravity, that fraction of a second might seem more like billions of years to an outside observer. That could be a reason we haven't seen a white hole yet. The universe is just too young, and most black holes are just too big. For now, although white holes sure would be a convenient way to explain a lot of the universe's biggest mysteries, there's a strong possibility that they're just not a thing. Still, some of Einstein's wilder predictions turned out to be true. Maybe we just need to wait another few billion years to find out.